Okay, this is a short video that then describes how we get from a density independent growth rate to a logistic curve. So what we mean by density independent is that R is independent of growth, not that population growth is independent of population size. So this means that R is not a function of n. R is constant, but that growth then, d and dt, is a function of both intrinsic growth rate and the population size. So what happens first is what we're going to do to modify this is to replace that intrinsic growth rate, a little r, that is independent of n, with something that is dependent on n. So we replace little r with an intrinsic birth rate, b sub o, and death rate, b sub o, modified by factors with coefficients a or c that describe how birth and death relate to n. And that's in the red in equation 2. So hence r is birth minus some factor times the population size, and death minus some factor times the population size. Okay, so then we can change that to we can insert that into the equation. That's in equation 2. And then we do some fancy math. And so we're effectively going to be multiplying by 1 and rearranging. And this is the confusing step. So let's go through this bit by bit. So first we factor out the intrinsic growth rate, little r, b sub o minus d sub o. You can take it out of both of those parentheses, and we pull it outside the parentheses. And then this leaves us with a factor that b sub o minus d sub o minus a plus c times n is that equation. So let's multiply by 1, and multiplying anything by 1 is itself. And so we're going to multiply by 1 in a particular form. That's b sub o minus d sub o over b sub o minus d sub o. So that's the unity, that's the 1. We then can extract b sub o minus d sub o, or the little r, outside the parentheses and end up with something that looks like that bottom line there. And I won't read through that with math, but this leads to the equation that you see above. And if you might need to pause and sort of think that through for a bit, but that's what happens. Then we're going to do some rearranging, and and we're also going to be declaring something called the carrying capacity. Notice that in equation 3 up there, in either form, we don't have anything that's called the carrying capacity. So what we're going to do is we're going to define the carrying capacity as related to how little r, birth minus death, is influenced by those coefficients that drive how that changes with density, so a and c. And so we're just arbitrarily calling that then k, carrying capacity. And so we can replace that factor, so birth minus death over the degree to which those things are influenced by density, down there at the bottom of this slide, k equals b sub o minus d sub o over a plus c. That's k, and we replace and we have the inverse of that in the equation up there on 4, so that's 1 over k. So we see that this simplifies down to saying b sub naught minus d sub naught, or little r, is equal to 1, which is up above on equation 4 there, b sub r divided by r. I think I have an extra parentheses in there right in here. Maybe I can take that out. Minus 1 over k times n, with n outside the whole parentheses. That's carried all the way up from here on equation 2 on down. So for the next line, for the third equation under 4, I'm going to move that n over to the other side of the parentheses, over by n, and so you have r times n, and is equal to 1 minus, and then here I'm going to take the n that's here in the second equation within the parenthesis bracket, and I'm going to put it over the k there. And so we have this form. It says that the population growth rate, d and dt, is equal to, as a function of the intrinsic growth rate, population size, and this factor, that relates to carrying capacity 1 minus n over k. Now you can rearrange minus 1 minus n over k to be k minus n over k, k minus n over k rather, and that this is the form that we've been using in class. Both of them work out to be the same. You can just simply think this through by looking at what happens when to that factor when n equals k, so k over on the third line, 1 minus n over k is n over k. When k equals n, that's 1, so 1 minus 1 is 0, and then that means the population growth rate is 0, or if n is very small, 1 minus 0 is 1, which means that it's like the exponential growth rate, and that works out the same down here on this fourth equation as well. So that's simply how that works. I hope that was helpful. Thanks.